Let's discuss the last topic, hypothesis testing here. Okay, so in hypothesis testing, hypothesis just means that we are trying to make a guess at something. Okay, so these are guesses. We've got two hypotheses because we need it to be kind of like a coin. If it's not the one hypothesis, it must be the other. So like if it's not a head, it must be a tail. When you have more than two options, if it's not a head, then could it be a tail or it could land on the edge or something like that. Okay, so we need our hypothesis to only come in pairs. Okay, so there are two hypotheses. One's called the null hypothesis, written like this, H with a little O, and the other is the alternative. This is H with a little a. Okay, so we usually say the null hypothesis, then we put a colon, and then we say what the null hypothesis is. Alternative hypothesis, and then state what it is. So hypotheses are guesses, and so we never make hypothesis about statistics. The reason that we don't do this is because a statistic is just a sample data. We don't have to guess about it because we already have it. We already know it. We don't guess it because we know it. We do use hypothesis on parameters. We guess at what mu is. We guess at what p is. We guess at what sigma is. We can guess at what n is, large N. Okay, so some examples. Here, the other thing to know is the null hypothesis is the hypothesis that expresses no change has occurred, and the alternative is when you're claiming something different or greater or smaller, something happened. So here are some examples. Maybe I'm making a hypothesis here, always on a parameter, that the population mean is equal to 7, or alternatively, it's greater than 7. Okay, maybe I'm making a hypothesis on the population proportion. Okay, so the null hypothesis is that P is 0.7, or the alternative is that P is less than 0.7. Or here you could also do P is equal to 0.5 versus P is not equal to 0.5. Okay, so those are some examples. Okay, so hypothesis must be mutually exclusive and all-encompassing. What I mean is there can't be any overlap. So here, this is an example of what you don't do. I guess that the mu is equal to 0.5, or mu is not equal to 0.4. See how these two numbers are different? It means that there is a possibility that both hypotheses could be correct. Maybe the mu is 0.5 and the mu is not equal to 4. Both of these hypotheses could theoretically be correct. So this is not allowed. It has to be mutually exclusive and all-encompassing. If it's not a head, it must be a tail. No in between, no overlap. Okay, so here then, the other thing that I need to do is make sure that every option is covered, okay, when I'm making my hypothesis. Okay, so a really popular example when you're talking about hypothesis is to think of it like a court trial. Okay, so here when you're trying somebody to see if they've done something wrong. In Canada, we've got the null hypothesis, which is that someone is innocent until they're proven guilty. There's been a question about whether they are innocent or guilty, so they come to court and they evaluate the evidence. Okay, so the null hypothesis is that they are innocent, and the alternative would be that they are guilty. So that's the idea of setting up a hypothesis. Okay, so here what you need to know is the null hypothesis, the two hypotheses are not on even ground. Okay, we will believe the null hypothesis unless we see something to change our mind. We will believe that someone is innocent unless we can show that they are not, or at least it's overwhelmingly obvious that they may not be. Okay, so here then, when we say what happens, we shouldn't necessarily say that the null hypothesis is true, okay? Because that's our default. We just always assume that it's true. Then if there is strong evidence, then we might say that HO is false. But we should never say that HO is true, because if somebody, let's say somebody has done a crime, but nobody knows about it, and you come to court and we look at the evidence and we say, well, there's not enough evidence to say that they've done this crime. That doesn't prove that they haven't. All it does is just not give us the evidence to say that they have done it. So we don't ever say that HO is proved or that HO is true. Conversely, we can say when HO is false if we seem to have shown that, but we can't ever say that it's true. So when it comes down to this, we have very special wording for this. We don't ever say that we we don't really ever say that we've proved HO is true. We say that we failed to reject that it's false. Okay, and so this is just wording that's trying to show you the subtle difference here. And the subtle difference is that by default we think HO is true. So if there's no evidence, then we would say HO is true, whether or not it is. So it's not that we are waiting to make a decision. We're making one decision, then we're seeing if there's a reason to change that decision. Okay, so just like in this court of law, when there's an issue of somebody's status, they enter a plea, then we will see the evidence. Okay, so just like that, we will set up a hypothesis and then we will look at sample data to see which hypothesis is supported. Now, setting up the hypothesis is extremely, extremely important. It's one of the only things that a computer can't do. So it's very, very necessary for us to know how to do it properly. Okay, so the thing that never lets me down is that the null hypothesis always contains the equal sign. Either the equal sign, the less than equal sign, or the greater than or equal sign. One of those three must always be in the null hypothesis. For example, mu is equal to 17, or p is equal or less than or equal to 0.5, or that mu is greater than or equal to 1027. Always, always, always have to have some sort of equal sign in the null hypothesis. Conversely, the alternative never has an equal sign. For example, here these two go together, they're pairs. Mu is equal to 17, alternatively, mu is not equal to 17. P is less than or equal to 0.5, alternatively, P is greater than 0.5. Okay, so it's the other side here. Mu is greater than or equal, and mu is less than. These things have their little partnerships. Okay, so let's practice setting up some hypotheses. If you want to test if a coin is fair, you would expect 50% of the time you toss it to be heads and 50% to be tails, if it is fair. So the null hypothesis is that the proportion of heads is equal to 0.5, and the alternative is that the proportion is not equal to 0.5. Okay, so here I've just said, is the coin fair? And the alternative would then be, is it not fair? Okay, proportions are always used for categoric data. When we're considering what kind of data, it is a head or a tail. This is not a numeric value. Therefore, we will use P for proportions. An Alberta doctor claims that the average cost of an MRI is less than $1,200. Okay, so here, average cost, okay, first of all it says average, that's one big giveaway, and cost, of course, is numeric. It is a measurement represented by a number. Okay, so here we know that the parameter should be mu. Okay, we look closely and they're saying the claim that's being made here, we're decoding these words, this word is less than 1,200. Not less than or equal, but less, strictly lower than. Okay, this sign, because it does not contain the equals sign at all, must be in the alternative. It doesn't have the equal sign. There's only one place for it to go, and that's the alternative. Therefore, here is the hypothesis. Mu is greater than or equal to $1,200. Alternatively, mu is less than $1,200. See how the equal sign must go in the null. Okay, there is another way to write this. It's always acceptable to write the null hypothesis with just the equal sign. You can also write it this way. So you could say mu is equal to $1,200 or mu is strictly less than $1,200. I personally prefer to write it this way because you can see the partnership that's going on between these two. It's fine for you to always write the equal sign in the null hypothesis, but you must have the correct sign in the alternative. Okay, so think of it as a statistical slang, where here maybe somebody's just a little too lazy to say greater than or equal. So they pick out of greater than or equal. So equal they choose. Okay, so let's continue. An economist wishes to test if the unemployment is higher than 6.4%. Okay, so higher means strictly more than, not higher than or equal to, but strictly more than. This is the greater than sign. Only one place for it to go is the alternative. Here we're talking about categoric. Do you have a job or not is some sort of question with categorical answers. So this is the null hypothesis, is that P is less than or equal to 0.064 and P is greater than, higher, this is the greater than sign, 0.064. Okay, notice here that this is a percentage and proportions are decimals, so I want to make sure to write this properly. This is 0.064, not 6.4. Okay, so researchers believe that chemotherapy treatment will prolong. Prolong means make more life. Okay, so greater than, not greater than or equal to, but prolong means actually an additional amount, not just the same or more. Okay, so that is the strictly greater than sign. Okay, that must go into the alternative. There is no equal sign with it. Okay, the average lifetime is 4.3. Okay, so here again, we're measuring the amount of time. This is a number, okay, a numeric value. And we're also talking about things like mean. This should be the null hypothesis. Mu is less than or equal to 4.3, or mu is greater than 4.3. Again, prolong is greater. You could also, of course, write the null hypothesis. Always acceptable to write the null hypothesis with the equal sign. The last one is extremely difficult. Okay, so the epidemiologist wants to see if better, that's the greater than sign, detection methods, and improved, that's the greater than sign, has decreased, that's the less than sign, stage 2 breast cancer fatality rate. So you have to really make sure you know what's going on here. Is it going to be the greater than sign or the less than sign? And you really have to ask yourself, what's being measured? So here P, or the proportion of death, is being measured. Here we're trying to see if the method has improved, which would mean if P is the proportion of death, improvement means smaller p. So you have to be careful. You have to very, very, very be careful. This is the only thing that the computer can't do. Okay, so you have to make sure you're doing it properly. Okay, so here we're trying to decrease the death rate or improve the method. So P is the proportion of death, then that must mean we've got the less than sign. So the proper way to write this would be proportion is less than 0.15 or 15% here. And the null hypothesis is that it was greater than or equal. Okay, so the last thing that I slapped on here is if you wanted to test the class average is 70%, is the parameter mu or p. Okay, so you can't just look at the percent sign. A percent sign doesn't always mean that it's a proportion. In this case, make sure you're talking about whether your data is numeric or not. Okay, the class average, okay, average is mu. Okay, here in this case, you've got numeric data, and you're talking about percentages as a unit. So here, the parameter would be mu, not p. Just because you see the percent sign doesn't guarantee that it is a p. Okay, you could talk about the proportion of students that passed, in which case it would be a percentage as well. 30% of students failed or something like that, or 70% of students passed, or whatever you want to say. In that case, you cannot, all I'm saying is you cannot simply just look at the percent sign to make sure if it's true or not.